Welcome, class. This week we're going to continue our study of prime factors and prime factor trees. And we're actually going to extend this and stretch this really into a very cool and important new idea this week. So let's take two numbers. How about the number 12 and the number 18? So in your math notebook, I would like you to please, you're going to follow along here with some notes, so make sure you're ready in your math notebook. Now, we're going to go ahead and record these two numbers here, 12 and 18. These are both composite numbers. That means I can divide them up. And I'm wondering, what is the greatest common factor, or what numbers can I divide 12 and 18 by? Or what's the biggest number that I can divide 12 and 18 by? This is a question that is going to be really important to some of the work that we're going to be doing here pretty soon. So we're going to explore some strategies here for how to divide 12 and 18 and to find some factors of them and what is their greatest common factor. So the first thing we're going to do here is we are going to divide, we're going to find the prime factor trees for both of these numbers. So for a prime factor tree, you'll remember we always start with the lowest prime factor, the lowest prime number, which is 12. So the question is, can I divide 12 by 2? That's the lowest prime number down here. Can I divide 12 by 2, or 2 times what equals 12? Let's see here. 2 times 6 equals 12. 2 is prime, so I'm going to underline it. My tree kind of ends right there. And now I have my new number. In fact, just for clarity here, I'm going to mark my prime numbers in red here, my composite numbers in green. When it's red, we kind of stop. It's like stop. Red means stop, green means go. And 6, I'm going to continue on with. Now, can I divide 6 by 2? Yes, I can. I'll go ahead and underline my 2 there. It's going to stop. Now, 6 times what? Or rather, 2 times what equals 6? That would be 2 times 3 equals 6. And 3 is also prime. I'm going to stop right there. Okay. So if you haven't already, make sure you're recording this in your math notebook. So I've done a prime factor tree for the number 12. I want to know, what is the greatest common factor of 12 and of 18? So I need to do a prime factor tree for 18 here as well. So go ahead and make sure you have the number 18 written down and see if you can try these first couple steps on your own. Can you make a prime factor tree for the number 18? Let's see here, we're going to start with the lowest prime number, which is 2. Can I divide 18 by 2? Yes, I can. 2 times what is 18? 2 times 9 is 18. All right, I'm going to stop at 2 over here. And 18 is composite, so we'll keep going. Let's see here. Can I divide 9 by 2? No, I can't divide 9 by 2. I have to divide it by something else. What do I divide? See, so I move on to the next prime number. Can I divide 9 by 3? Yes, I can. 3 times 3 equals 9. Now those are both prime numbers, so I'm going to stop right there with both of those. So now I have my prime factor trees done for the number 12 and the number 18. Here's the important step. Make sure that you have your math notebook ready, and that you're ready to take some notes. So, step 1, make a prime factor tree for both numbers. Write this down. I'll just explain how to do it first. So, the first thing I'm going to do is I'm going to circle any pairs of numbers any prime numbers that these both have in common. I only circle pairs from both numbers like this. 2 and 2. That's a pair. I'm going to write my pair down here. 2, that's one pair. Can I find any more pairs in these numbers down here? Any more numbers that they both have in common? 2 and 3 are not the same, but 3 and 3 are the same. So I'm going to circle that pair, 3 and 3. Now notice that I am not circling these two as a pair because they're in the same prime factor tree. I'm circling pairs between the two prime factor trees here. So that would be a 3 and a 3. That's another pair times 3. Are there any more pairs? Well, all that's left is this 2 and this 3. That is not a pair. They're not the same number. So I'm not going to circle them. And I have 2 times 3 equals 6. What that means is that I can divide, 6 is the biggest factor. Remember, a factor is a number I can divide by. 6 is the biggest factor of 12 and 18. I can divide 12 by 6. 12 divided by 6 equals 2. I can also divide 18 by 6. 18 divided by 6 equals 3. I can divide both of these numbers by 6. In fact, it's the biggest number that I can divide both of these numbers by. Now, I can divide 12 by 2. I can divide 18 by 2. I can divide them both by 3 as well. But the biggest number I can divide them both by is the number 6. So that is a prime factor tree. In the next video, I'm going to go ahead and solve another one of these, and I'm going to have you try it on your own. So go ahead and start watching the next video after you're done taking your notes here. Actually, first let's write down these steps. So step 1 is make a prime factor tree for each composite number. Step 2 is circle the pairs, and let's underline the word pairs. Circle the pairs of matching numbers, and make sure that the pairs are in matching numbers in both trees, not in the same tree. And step 3 is multiply the pairs. Multiply the pairs. Those are the 3 steps. So pause if you need to. Make sure you have all these steps down. Then you can watch the next video where we're going to practice this together a couple times.